Hey class, so I wanted to make a video on 3.5 Objective 6 because I was still receiving questions about how to do certain things. So in Objective 6, we want to determine the equation of a function given its graph. And remember that in this section, we're mainly talking about functions of this form. So y equals a sine bx, and y equals y equals, that was weird. I have no idea why it's doing that. Anyway, y equals a cosine bx. Sorry about that. So these are the functions that we're mainly trying to decipher from these graphs. And let's just get into how we do this. So there's a three-step approach that you can take in order to determine this equation. And I can boil these three steps down into some simple instructions. So the first step, step one, you're going to want to know, where does this function start? So where does your function start? If I drew something that looked like this, and it started right here on the 0, ask yourself what function that would be. As opposed to if I started a function like this, where it started up here, ask yourself what kind of function this would be. And what you should come up with as the answer for this is, for this function, when it starts on the 0, you should be looking at functions that look like a sine bx. Because remember, the y-intercept for sine is going to be 0. So any function that starts on the 0 will be some sort of sine function. If it does not start on the 0, it starts up here, then we should be talking about y equals a cosine bx. Because remember, the cosine y-intercept was +1 when you were dealing with a positive cosine function, and -1 when we were dealing with a negative cosine function. Okay, so now step 2 is going to be basically the opposite of this. So in step 1, we're talking about where it starts to get the form of this graph. In step 2, we're going to be looking at where this function ends. So I'm just going to draw the positive cosine for this. I want to know where it ends. So kind of like draw a dotted line there. Okay. Where this line ends is going to tell you the what of the function. So if I wrote 2 pi on both of these ends, ask yourself what this means for this function. What is it called? So this 2 pi that I've written at the end is going to be the period of our two functions. So the period of each of these graphs is 2 pi. Remember, the period tells you where the first cycle stops and that second cycle begins. So past 2 pi, we're going to start going up again and repeating this first wave. Same goes for cosine. Once we get the period, we need to figure out how that factors into this equation, right? And the period's actually just going to tell us or allow us to find this b inside the parentheses. Because remember that when we were dealing with the quarter points, we wanted to find the period of this function by taking this b and dividing it by 2 pi. Okay? And yeah, this b and dividing it by 2 pi. So we called this, oh, I'm sorry, I wrote this wrong. Maybe something left off. So we didn't divide b by 2 pi, we divided 2 pi by b. And we called that the period. So we can rewrite this formula in order to see how we can get b from the period. And what we can do is multiply b over to get the period times b. and then we can divide by our period to get 2 pi divided by p is equal to b. So when you answer the question, where does it end, you'll find this period and you'll be able to solve for then your b, which you're going to plug into your function. So in this case, where the period is 2 pi, we're going to get b is equal to 2 pi divided by 2 pi, which is equal to 1. Okay, so now we have the form of our function and we have the like this stuff in the parentheses. So now we want to look at what is a. So what's in front of our sine or cosine function. And here we're going to need two different things. So we're going to need the sign of this a. This a can be positive or negative. And we need the value as far as the number associated with it. So if this was 4 and down here was -4, this would tell us that the range of this function is -4 to 4, right? Because its minimum is -4 and its maximum is 4. So remember that this range tells you the amplitude of our function. So this amplitude is going to be 4. The important thing to note is that the amplitude was always an absolute value of this a coefficient. So I'm going to show you another pair of examples to illustrate this point. I can draw two different sine functions, one like this and one like this. These could still have the same ranges if I make the max 4 and the min -4. However, these both have two separate a coefficients. So in this case, let me do this case first. In this case, a is just a +4, right? We start going upwards and then go down. This is a positive sine wave. However, in this example, we see that it's flipped along the x-axis. It's mirrored from this function right here. So that means our a is actually going to be a -4. Okay. For cosine, we'd have graphs that look like this. The positive version would be here, so I'll just use 4 again, so this would be a +4. And this right here would give us a is equal to -4. So you really want to look for cosine where it starts. If it starts on the positive side of your y-axis, then it's a positive a. If it starts on the negative side of your y-axis, then it's a negative a. Or I shouldn't say negative a, it's a negative number. For sine, you look at where it kind of heads. If it heads up in the upwards direction, your a is positive. If it heads downward in this direction, then it's a negative. So let's put all of this information together, and we can do it with this example right here. So the amplitude for this function was 4, and since it starts going up first, that means that our a coefficient is positive. We already found that the b is 1 because the period was 2 pi. Therefore, putting all this together, we see that y is equal to 4 sine of x. Whenever you get 1 for your b coefficient, you don't have to put 1 into your function because any variable standing alone, it's understood that a 1 is multiplying. Okay? So let's do another example now that I've kind of explained these 3 steps. And yeah, let's see how that goes. Okay, so here's another example, and I'm going to walk you through this one really quickly, just so that way I can let you do the next example on your own and see how you do. So here, the first thing I would notice is that it has a max of 2 and a min of -2. So that means we have -2, 2. Actually, the first thing I should have noticed was what kind of function is this? Well, since it starts at the 0, then we're dealing with y equals a sine bx. So we're dealing with a sine wave. And then we can start talking about, how high it goes, where it starts and where it stops. So it starts at 0, it stops at 2 pi. That means the period of this is going to be 2 pi. Again, we can find b by taking 2 pi and dividing that by p. And in this case, again, we see that 2 pi divided by 2 pi is equal to 1. So our b is just 1. But now we kind of take the final step, and we see that the amplitude for this is equal to 2, because our range is -2 to 2. However, this sine function starts by heading in the downward direction. So that means that our coefficient a is actually a -2. So for this example, we get y is equal to -2 sine of x. Okay, so once you write down this example, I'll go on to the next. Okay, here we have another example, and I want you to pause the video and try to figure this solution by yourself. Just to highlight this, I know some people were having trouble seeing this in class. This right here is a 6 times pi. Okay, so go ahead and try to solve this, and I'll talk about the solution in a second. Okay, so your solution should have been y equals 4 sine of a third x. And if you're wondering how I got this, first we can note the 4 and -4, which gives us our range. It starts by going upwards. So this gives us a positive a coefficient of 4. Also, it is a sine function. Hopefully you noticed that, at least. And lastly, we have the period of 6 pi. So we take 2 pi divided by our period, and this gives us 1/3, which will be our b coefficient. So I'll leave you with one last example. And here it is. So go ahead, try to solve this, and I'll talk about the solution in a second. For this example, you should have found that y is equal to -4/3 cosine 5x. Okay, so to highlight how we got this, first you can note that this function starts on the negative side of your y-axis. Since this is the case, we know that we're dealing with a negative cosine function. So we can use this point right here to tell what our a is going to be. You could have similarly looked at its min and max, so its max is 4/3, its min is -4/3. So that means that not only are we dealing with a negative cosine function, but that also means that this a coefficient is going to be equal to -4/3. The second and really the last thing to note is where it ends. So it ends at 2 pi over 5, and this is our period. So again, we divide 2 pi by our period, so we get 2 pi divided by 2 pi over 5. And remember that dividing by a fraction is the same as multiplying by that fraction's reciprocal. So we cross out these 2 pi's, and we're left with our b coefficient equaling 5. Putting all of this together, we get our solution. Okay, so that is it for this objective. I hope this cleared things up, and I'll talk to y'all next time.